All right, guys, so today we're learning congruence theorem. So yesterday we talked about side-side-side congruence theorem. So you can prove that two triangles are congruent if all three sides are the same. Today we're going to be learning about the other most common congruence theorem, which is side-angle side. So we're first going to start by proving side-angle side through construction. So let's turn to problem 1. Okay, here's what I want you guys to do right now. Pick one person in your group to read paragraph 1, pick someone else to read paragraph 2, and pick a third person to read paragraph 3 to your group. So basically what this is saying is that we have another way of proving congruence, and that is using the side-angle side congruence theorem. So the theorem states that if two sides and what is called the included angle of a triangle are congruent to the corresponding sides and included angle of the second triangle, then the two triangles are congruent. The included angle is the angle formed by two sides of the triangle. So once we draw a triangle, I'll show you kind of what that means, but it means that the angle that's formed by the two sides. So it has to be a side, the angle in between, and then the other side. Does that make sense? So that's going to be your side angle side. So what we're going to do first is we are going to prove that this is true using construction. So for part 1, I give you line segment AB, I give you line segment AC, and then I give you angle A. Any ideas as to how we can construct triangle ABC using these three pieces of information? Okay, we can measure the sides. What part do you think we need to copy first? Would it be easier for us to copy the angle first or the sides first? What will help us? Okay, so Tong says if we copy the sides, we can make an arc and then intersect them. My question is, if I were to copy AB, how would I know where to put AC? Because the angle has to be on point A. Anybody? Does it matter? It does matter because we have to have that angle that's exactly the same. So here,
copy AB and then put the angle on there.
Okay, so Dana says, what if we copy AB and then we can do the angle and then we can copy AC on that line? Let's try it. So let's do a starter line first. So you guys can use your the straight side of your protractor because we are going to use those in a second. So draw a starter angle. Or a starter line, sorry. Mine's not very straight. Remember, starter lines have arrows. Draw point A. And let's start by copying AB. Okay, so let's copy line segment AB. You guys should be pro at this by now. So we have AB. Does anybody remember how to copy an angle? Any ideas? Yep, we pick a point. So on the angle, we have to draw an arc that goes through the angle that will go through both sides. So do that. And then we have to measure this part right here. So we have to look at the distance between the two intersection points. Oh wait, first we make, hold on, I'm just kidding. Then we make that arc on our starter line, right? So you made on your angle, you have to make the same arc on your starter line because we have to know where to put our compass. So this arc and this arc should be the same, right? And then we measure the distance on our original angle between the two intersection points. And we have to make that intersection point on our new, where we're copying it. Okay? Well, what I would, yeah, you can put a little point there. Don't make it too big because that's could not necessarily AC, but do draw a line through it. So draw the line through it because we know that that's AC has to be on that line. but we need to now measure the length of AC. So then measure the length of AC and draw it on that line that we just made. So here is C. So we have A, B, and C, so draw that triangle. Okay. So your triangle should look something like that. I'm going to outline mine in 10. Okay. So it really didn't matter if we constructed AB and then the angle and then AC. We could have also done the angle and then the two segments. Okay. But your triangle should look like that. So I'm going to write those steps out just so that we can do it later. So the first step that we did was we copied angle A. Let's copy angle A. And then we copied AB and AC on the legs of angle A. Okay? So just in case we need to do it again, that's what we did. We copied the angle, and then from that angle, we can draw segment AB and segment AC. And that makes, and then the last step then would be to draw a triangle ABC. Okay? Some of yours might look slightly different than mine. So here's what I want you guys to do. On the other side of this, I want you to answer questions 2, 3, and 4. And 5. So answer questions 2 through 5 on the other page that have to do with the measures of your angles, the measures of your lines, and we're going to determine if your triangle is congruent to your partner's triangle. First of all, how did the length of side BC compare to the length of your classmate's BC? What did you guys get about the length of BC? They are the same. The length should have been the same, right? Of BC. BC is the side that we drew that we didn't copy. So AB, everybody should be the same because they gave us AB, right? And AC, everyone should be the same because we just copied it. So BC, everybody's BC should have been the same, yes? Okay. So then did anybody measure angle B and angle C? What did you guys get for the measure of angle B? Somebody got 40, somebody got 35. Can I borrow some of your compass? Let me measure mine, or I mean protractor, sorry. So let me measure mine. So angle B, remember we put our protractor where it crosses right on the angle, make sure it's all lined up. Mine I'm getting 35, 37. On mine I'm getting 37. Everybody should be around 35 to 40, yes? Okay, so I got 37 on mine. Did anybody get the measure of angle C? You got what? 110. I have like 111. 110. Actually, no. Here's 110. Here's 105. I have like 103 on mine. So yours should be somewhere in between 100 and 110, somewhere in there. Okay, so I got 103. Okay, they should be close. Everybody's is probably a little bit different just because of the the error in the way you draw. If your lines aren't perfectly straight, however big you made the point when you were graphing, but they should have been very, very close. If you were the one graphing two different triangles, then they should have come out exactly the same. So what do you guys notice about the corresponding angles? They are congruent to your neighbors, or they should have been super, super close, okay? So, is your triangle congruent to the other triangles of the people group? It's supposed to be, because all of the angles should have been the same, and all of the sides should have been the same. So everything should have been congruent. So my next question to you guys is this. What if I gave you one of the non-included angles instead of angle A? Do you think everyone would have constructed an identical triangle? So, if I gave you, instead of angle A, I gave you angle C or angle B, but I still made you do AB and AC. The included angle in this triangle, since we are given AC and we are given AB, the included angle in there is A. Does that make sense? It's the angle that's made by AC and AB, so the included angle is the one that's in the middle. What if I didn't give you that? What if I gave you AC and AB, but then I either gave you the measure of C or the measure of B? I did not give you the included angle. Do you think our triangles would have all come out congruent? Talk about it with your groups. Okay, by raise of hands, how many of you guys came up with yes, you would have still got congruent triangles? How many people said no, you would not have got congruent triangles? Okay, the answer is no. Why? You have to have the included angle, because think about it. Does the opening of my angle, does that determine how long my sides are?
Yeah.
Think about it. What if I give you this angle? Here, let me do this on a separate piece of paper. If I give you, here's a segment. Let's call it ABC. And then I give you this guy. We'll call it EFG. Now, say I tell you that AB is, or ABC, the angle is 30 degrees, and the angle EFG is also 30 degrees. Are the segments the same length? The segments is AB congruent to EF?
No.
Is BC congruent to FG?
No.
So can I have two angles that are open the same amount but have different segment lengths? Yes, it's very possible. Say I give you, here, let's make them a triangle. Are these triangles congruent? No, even though they have the same angle. So the opening of the angle does not determine how long the sides are. That's why for side angle side, you have to have the included angle as part of it, because we know that this length is the same because it's given. We know this length is the same because it's given. So if the angles in the middle are the same, we know we have half of the triangle that's exactly the same. So you have to have the included angle in order to be congruent by side angle side. So that's the reason. You have to have the included angle. And that's why we listed as side angle side, because when you're going around the triangle, you know the side is congruent, you know the middle angle is congruent, and you know the other side is congruent. Okay? So I do want you to write that in your notes in part 6. You must have the included angle. So you must have the included angle because angle measure does not determine side length. Okay, so what that is saying is that if I gave you segment AB and segment AC, but I gave you a different measure for, say, angle B, we could have drawn a whole bunch of different triangles because it's not the included angle. Okay, so you have to have the included angle there. Okay.